Hi everyone, welcome to a short webinar from Mondoo. We're going to be talking about securing AI while the room is on fire. Of course, this is fine. My name is Dom. I'm a lifelong coder, hacker, pentester, and I'm going to be walking you through all of the things that have changed, particularly in these last 6 months, and what that means for us when we are trying to secure our companies. All right, so you have probably noticed that this has been the fastest moving attack surface we've ever seen in history. All the way up until RSA, I was typically showing this chart about how new vulnerabilities are getting released. New vulnerabilities are skyrocketing. Look at what the numbers are doing. This was 2025. This is 2026. In 2026, we have seen the number of vulnerabilities truly explode, especially when it comes to critical and high vulnerabilities, i.e. the ones that are going to screw your organization over the most. We've also seen that the window in which exploits are being released has been collapsing. I still remember when it was a couple of years. If you go back here, 2018, it was still at a couple of years for exploit on average. Then in 2024, it's really been going down to days. We've been moving our SLA windows, but honestly, these old SLA windows that we have seen, where it's like 30 days or 14 days, they're really not current anymore. If you look at 2026, it's all the way down to 10 hours. Some people even measure it into the negatives now, i.e. the exploits are out there before the CVE release process is actually going through. We also know that it's become easier to generate these exploits with the help of AI. So, a couple of dollars can get you an exploit. And if that exploit unlocks the door to your company, you got a problem. We also know that the adoption of AI has been an absolute boom in terms of how organizations are embracing it in different departments. In IT, more so than in some other parts, of course, manufacturing at the bottom end. But what this does show you is that everybody is rolling it out in one way or another. And we aren't just talking about the Gen AI of last year anymore. This year, we're talking about agents being rolled out and people installing apps on their systems, half of which are not really managed as well as they should. I think the old school endpoint management that we have had has really been struggling with these new methods that are coming out there and the degree to which these agents are actually able to run and execute code on your machine. So let's talk about two things here today. One is I'm going to walk you through Shadow AI, i.e. we're going to look at AI security and the Shadow IT on endpoints. And then we're going to do part two, where we talk about remediation, i.e. how do we go about fixing these things and tackling these curves that I've shown you earlier. Like, what do you need to change in order to catch up with this level of release of vulnerabilities? So let's do part one first. This is about Shadow AI, i.e. first of all, you need to understand what your AI footprint is out there. You can't secure what you can't see, obviously. So yeah, AI has been a risk that has moved to the endpoints. I think a lot of people that I talked to so far have been aware about the server-side risks of it, i.e. making sure that your agents there and the configuration on the servers are secure. But a lot of people are forgetting that their endpoints actually oftentimes hold the keys to their company, i.e. they have people that have access to a wide range of systems. We know from the benchmarks that's been done and the surveys that a lot of CISOs fear these AI agents, and yet you can't really stop your company. You can't really hold them back. Please don't adopt AI yet. Give us a couple more years to figure this out. It just won't hold. We know that a lot of the safeguards really aren't there in order to keep the endpoints secure. So we actually went out there and we did two things in order to improve the situation. The first one was that we created an AI bill of materials. You might have heard of the software bill of materials before, the SBOMs. SBOMs have been fantastic ever since their inception because they give us a footprint of all the software that is installed on somebody's system. Could be a server, could be a container, or could be an endpoint. The AI bomb that we have created here does the same thing, but it extends it into the different artifacts that we find with AI agents, i.e. the agents themselves, which is largely software, of course, but there's also some plugins that are being captured, skills, MCP servers, models, guardrails, and other things. All of that is being captured in an AI bomb. With that AI footprint, we are then starting to understand your organization better, i.e., where are the agents and what do they have access to? If you think about them like other pieces of software that can be exploited, you need to understand what kind of agents are being deployed and what they have access to. Could be repositories, could be APIs. A lot of these agents, we're automating our daily lives, so we give them all the access that they need to. And if an attacker exploits that, they can do the same things that an agent can potentially do. From here, let me show you 3 quick examples about endpoint vulnerabilities that we have seen out there. The first one being DuneSlide. DuneSlide is a CVE that was used to bypass the command execution in Cursor. Cursor, of course, being as popular as it is oftentimes installed. And this vulnerability or this exploit was able to be triggered with content, i.e., as long as the agent read the malicious content, we were able to exploit this vulnerability. These are remote code executions, so these are particularly nasty because they allow us as an attacker to run arbitrary commands to extract tokens, cloud keys, and so on. All the yummy things that pen testers and hackers really like. We know from context here, so typically we would go out and we would analyze all the assets that are affected by this, and then we look at the context, i.e. what is the blast radius, and that means what does the asset have access to, and then what is the exposure. For some of these, of course, you didn't have to have it as a listening service. Obviously, it's enough if you can get the user to use the malicious content in order to exploit it. Blast radius comes afterwards, so it is all the systems that I have access to downstream, and the bigger the blast radius, the higher the more attention you need to pay to it, the higher are the risks. So here's an example. If I have a dev laptop, that dev laptop may have access to CI/CD systems, i.e. your pipelines that are rolling things out. I know that there are plenty of organizations that have bypass rules in CI/CDs when things go wrong. There are ways to get code in when you need to. That's fairly dangerous. Then there are registries that you can publish into. And remember, it's not necessarily your prime sources that may get modified here. It may just be something like a library that's get pulled by a larger source. Other credentials that we have access to, GitHub, Git, SSH keys, and so on. Another example that we saw was in MCP. MCP2, wonderful API, of course, very useful, but also here, it is possible to find remote code executions, especially in the underlying frameworks that exist. In this case, this was sitting underneath a handful of agents that were all affected, and thus this was a server-side remote code execution where you were able to run commands similar to the previous one. And then the last one is about agent skills. AI skills and the agent skills are often something that people don't really pay attention to. It feels like it's just some kind of text that your agent reads, as long as the agent is secure, you're secure. But oftentimes the way that we deploy agents, there's like a what the hell effect when we have had it with all the questions that it's asking us about permissions. And we typically open it up and allow it to do a whole bunch of things, including API access that that as an attacker I can use. We have been analyzing a lot of the skills out there for attack vectors. We're treating skills as code. Do not just treat them like a random markdown file, like a text file that's just sitting around where nothing can happen. Actually, skills can very much run code and potentially be a danger to your system. There's also ways to hide yourself within skills that have been installed because they are not as cleanly managed as they should be. So when you treat skills like a dependency, you actually go through the steps of static analysis, but then also a lot of AI analysis, i.e. machine learning classification and ML threat analyses. And you are generally trying to pen test the skill itself. This is what we're doing with our registry and also internally for all the skills that we analyze. So these are just a couple of examples where you can see the fire that is out there, that is potentially brewing on your endpoints. And this is the reason why we have started to get more visibility into how AI is being used on all of those endpoints. Okay, it's time to get it fixed. So I showed you the curve before about how vulnerabilities have really picked up. In order to fix this, you actually need to change the way that you approach remediation. I know that there are people that will argue that, oh, it's enough to put a bigger firewall in front of it. And while I always support a stronger, better firewall, I also know that a lot of networks are segmented in a way where as an attacker, I'm basically taking a step-by-step process. And if you make it easier for somebody like me, who gets through the outer layers to then go and step through the inner layers, those vulnerabilities on those systems are an easy gate to move around. So the way that we are looking at the process now is no longer the old vulnerability process of discovering, unifying, prioritizing, and so on. We're now looking at it as a analyze, plan, and ship state. Plan is oftentimes what organizations forget. You think that you're done when you have the prioritized list of findings, but I'm here to tell you that that's not the case. The prioritized list of findings is really what informs the second big step, which is the plan into the execution. And then finally, the last step, which is shipping, which should be driven by automation. So let me talk a little bit about that plan step. The first thing that you are trying to understand when you're going into a plan is, what are your goals? Your goals can be that you have SLAs that you're trying to keep, like the SLAs that we mentioned previously, but hopefully with a shorter range of days. So in that case, you would be looking for vulnerabilities that need fixing now, because if you don't fix them, they're going to burn that SLA down. You don't want that. Then there are goals where people just say, hey, I just want to fix a whole bunch of vulnerabilities, give me some high quality CVEs, and let's just do something that is easy. That is fine. It just means that you build up momentum when it comes to your fixing journey. I always encourage get to momentum first. Don't get stuck on something because you're really trying to pick up speed with this. And then the last one is when you're actually trying to move the needle. Moving the needle is when you fix the vulnerabilities that will altogether make a difference in the risk posture of your environments. So for example, fixing 2 vulnerabilities in an app doesn't help you so much if the same service is exposed on another port where that fix didn't really do anything. So set your goals first. Once you have your goals, you're really trying to look at the problems as mitigation versus remediation. Whenever it's possible and the remediations are easy to execute, of course, do it, implement it, roll it out. Always go for the remediation when it is available. But sometimes the remediations are very difficult, and you don't want to wait for a week or two in order to get to that magical maintenance window where you can safely, take down the servers and incrementally roll out all the changes. If you do run into these cases where critical RCE, for example, is out, you want to close those as quickly as possible. And so this is where mitigations come in. Mitigations are, for example, you put a firewall layer in between, you turn off the service, or you change the way that it is exposed to users or to other networks. Mitigations are often faster to do than a complicated fix that is out there. And so when it comes to closing the hole, that is always a good first step. Of course, your security tools need to understand that you mitigated something and reduce the risk accordingly, because you don't want to be bothered by the critical vulnerability for the next 2 weeks while you wait for that maintenance window. Something that we do, for example. And then lastly are operational risks. I know we're in security, right? Like operations, that's the other people. Those are the devs and the platform engineers. This isn't really our thing to do. But I'm here to tell you that when you provide a lot of these insights for your team ahead of time, it makes their job a lot easier. And when their job is easier, they actually get to fixing more and fixing faster. So I do think that the way that we as security work with platform and engineering teams really needs to change. And this is one of the ways in which we are providing more insights to developers or to admins about what a proposed remediation or fix is about to do to your systems. Honestly, if it's requiring like a pretty lengthy restart, if there aren't any rollbacks, and we're telling them, hey, this is going to be complicated to roll back. You might need to create a whole snapshot from the database, make sure that you are taking care of these things before you run this update. Or if we have seen that an update is actually riskier than another one, and just give them a heads up. This is going to increase the trust in the remediations that we provide, and then we understand what they are going through as well. Now, the last step in looking at this, we're looking at remediations, we're looking at mitigations. The last step are exceptions. Exceptions are just a daily part of the business when you're running something through. But I have seen most organizations treat them as an afterthought. So if the way that you're doing your exceptions is still through a manual process where you have to submit a ticket, or maybe it's a lengthy email. Again, I understand why it's hard to change this, but also it is really, really difficult for somebody that analyzed these vulnerabilities to go through a manual step-by-step process of allocating all of these exceptions. If you already have the insights from the remediations and from the vulnerabilities that you need an exception, make sure that you increase the automation of this process as well. In a lot of cases, for example, we have realized that something cannot be closed immediately, but there is a mitigation already in place, or there is an exception where we test these things out that we need because some customer will be affected if we turn off a certain feature, for example, in TLS. And so we may need to accept the risk for the time being. Automating this process makes it easier, makes this entire flow go faster. And then before you roll things out, remember the pre-flight checks, especially to collect the indicators of compromise, making sure that you understand the scope of the targets that you're about to roll out to. And then everybody loves the recovery, but nobody likes to do backups. But if you do require the backups, it's an important pre-flight check. Rollbacks, you do want to consider, are rollbacks even possible? Like I said before, you want to have that awareness before you push these changes out. And even if you do that, there are potential downtimes and maybe risks associated with it that you want to understand before you roll this out. Now, planning is the step that helps you get into a faster execution. And the execution itself these days, honestly, should be driven with as much automation as you can. I understand that not every organization has all of the bells and whistles here attached, has large teams that focus on the automation of their infrastructure. I understand it's sometimes just a few people that are managing a huge environment. In this case, in order to do that, automation is king. We have been using automation, for example, to roll out fixes to endpoints, as well as to roll out fixes to servers, cloud infrastructure, and internal networks. In these cases, the automation really just helps us to execute these steps faster, but then to also deal better with errors if things go wrong, and to make sure that you have every single step covered, notifications, logs, and so on. When you do this right and you follow this entire process that I just showed you from the analyze, plan, and ship step, you can actually put this entire loop into a automatic loop, i.e. it becomes a preventative control that sits within your environment. So when you understand the rules, the decision rules that you're taking here in the middle, You can take the analysis of the inventory, the proposed fixes, and the operational risks. And in a lot of cases, you can automate the decision making that you need on it, as well as the rollout through the workflows that I just showed you. Modern security needs these things to handle the vast majority of all the cases that are coming up, 80, 90+%. I think as we are going forward, this is how the majority of all issues will be fixed ahead of time, and then we're going to be dealing with the edge cases and the difficult capabilities that customers still require from us. The automation that you need to put in place, you need to be able to trust. Agents are great at rolling out different capabilities with different jobs. For example, we've got agents that analyze the attack surface or the blast radius. We've got agents for the operational considerations or rollbacks, as well as the ones that are rolling things out through automation tools. The fixing step itself, again, big recommendation, stick to the tools that are out there. Don't try to reinvent the wheel. If your security provider thinks that they can do a better job providing a server management system or cloud management system than these players out there, good luck. I believe in using standardized technology that is out there and using it well. If you cannot roll it out yet, like let's say, for instance, you're a smaller organization, you don't really have this whole Terraform footprint or Intune and so on, any of these technologies out there, there are ways to set them up, especially these days with agents in a more lightweight way, and then have them be managed. As long as we use standardized solution, I believe we'll do a better job at fixing and maintaining that loop. If you do all these steps well, your remediation curve will look a little bit more like this. This is with a real customer of ours where we ran through this. In the beginning, they had a problem with their remediation speed that they also identified. We were able to detect more and more vulnerabilities on the systems, but remediation wasn't catching up. Just resetting alone is also not fixing the problem. If you follow some of the advice that I've given you here earlier about making sure the risks are real, understood, that the fixes are well understood and can be rolled out, that the decisions that need to be made are thought through from the beginning, then that can help you with your remediation game as well. So yeah, if you have any interest in the things that I've told you about today in shadow AI or in the speed of remediation, feel free to reach out to us. Feel free to ping me as well. This was a talk that was given at Black Hat, but we are at all major security conferences and available on mondoo.com as well. Thanks for joining me here today. Thanks for listening to all of this. I hope this was helpful. Hope to see you again next time.